Ground fault circuit interrupter protection is required. According to the National Electrical Code 2023, ground fault circuit interrupters are required for all 125-volt single-phase 15 and 20 amp receptacles installed in or within 6 feet of the outside edge of the following locations: kitchen sinks, lavatory basins, bathtub areas, showers, laundry areas, crawl spaces, unfinished basements, garages, and outdoors. The National Electrical Code recognizes that these areas are prone to water spills and contact, increasing the risk of electrical shock. Ground fault circuit interrupters are designed to trip and cut off power when electrical current leaks to ground, protecting individuals from potentially fatal shock hazards. In this case, the receptacle under the sink that powers the sump pump and instantaneous water heater is within 6 feet of the kitchen sink and is therefore required to be ground fault circuit interrupter protected. It is possible that the ground fault circuit interrupter may trip occasionally due to the normal operation of the sump pump and water heater. To mitigate this issue, firstly, use a dedicated ground fault circuit interrupter outlet for these appliances only, and secondly, consider using a ground fault circuit interrupter with a time delay feature to reduce nuisance tripping. Based on the National Electrical Code, the receptacle under the sink is required to be ground fault circuit interrupter protected to ensure the safety of individuals in the event of an electrical fault. While occasional tripping may occur, it is manageable with appropriate measures. The key requirement centers around the proximity to a kitchen sink, specifically being within 6 feet. The National Electrical Code mandates ground fault circuit interrupter protection in such locations due to the increased risk of electrical shock in wet environments. The purpose of a ground fault circuit interrupter is to detect imbalances in the electrical current, indicating a potential leakage to ground. This leakage could occur if someone were to come into contact with a live wire while also being grounded, for instance, by touching a metal sink or standing on a wet floor. When a ground fault circuit interrupter detects this imbalance, it quickly trips, cutting off the power and preventing a potentially fatal electric shock. The presence of a sump pump and an instantaneous water heater introduces additional considerations. These appliances, by their nature, involve water and electrical components in close proximity. The sump pump is designed to remove water, while the instantaneous water heater heats water on demand. Both appliances increase the potential for water to come into contact with electrical components, further emphasizing the need for ground fault circuit interrupter protection. There are instances where the normal operation of a sump pump or an instantaneous water heater might cause a ground fault circuit interrupter to trip. This can occur due to slight leakage currents within the appliances themselves. While these leakage currents are not necessarily dangerous, they can be sufficient to trigger a ground fault circuit interrupter, leading to what is known as nuisance tripping. To address potential nuisance tripping, there are several strategies to employ. Firstly, ensure that the sump pump and instantaneous water heater are properly grounded. A good ground connection provides a safe path for any leakage current, minimizing the likelihood of it triggering the ground fault circuit interrupter. Secondly, consider using a dedicated ground fault circuit interrupter outlet specifically for these appliances. This isolates them from other electrical loads, reducing the chance of interference or cumulative leakage currents causing a trip. Thirdly, investigate the use of a ground fault circuit interrupter with a time delay feature. These ground fault circuit interrupters are designed to tolerate brief, harmless leakage currents without tripping, while still providing protection against more significant and dangerous ground faults. It is important to note that ground fault circuit interrupters are not designed to prevent overloads or short circuits. These types of faults are typically handled by circuit breakers. A ground fault circuit interrupter is specifically designed to detect ground faults, which are different from overloads or short circuits. Overloads occur when the circuit is drawing more current than it is designed to handle, while short circuits occur when there is a direct, low-resistance connection between 2 points in the circuit. In addition to the National Electrical Code requirements, local electrical codes may also have specific regulations regarding ground fault circuit interrupter protection. It is always a good idea to consult with a qualified electrician to ensure compliance with all applicable codes. When installing or replacing a ground fault circuit interrupter, it is crucial to follow the manufacturer's instructions carefully. Incorrect installation can render the ground fault circuit interrupter ineffective or even create a safety hazard. Regular testing of ground fault circuit interrupters is also recommended to ensure that they are functioning properly. Most ground fault circuit interrupters have a test button that simulates a ground fault, allowing you to verify that the device is tripping as it should. Testing should be performed at least monthly or according to the manufacturer's recommendations. Furthermore, it is essential to understand the difference between a ground fault circuit interrupter and a ground fault equipment protection device. While both devices protect against ground faults, they do so at different levels. A ground fault circuit interrupter is designed to protect people from electrical shock, while a ground fault equipment protection device is designed to protect equipment from damage. Ground fault circuit interrupters trip at a much lower current level than ground fault equipment protection devices, typically around 5 mA, to provide a quick response to potential shock hazards. In the context of the office kitchenette with a sump pump and instantaneous water heater, the primary concern is the safety of individuals using the space. Therefore, ground fault circuit interrupter protection is the appropriate choice for the receptacle under the sink. While ground fault equipment protection might be used in other applications to protect sensitive electronic equipment, it is not a substitute for ground fault circuit interrupter protection in areas where people are at risk of electrical shock. It is important to differentiate between required ground fault circuit interrupter protection and other types of electrical safety measures. While surge protectors, for example, can protect electronic devices from voltage spikes, they do not provide protection against ground faults. Similarly, arc fault circuit interrupters, or RFCIs, protect against arc faults, which are a different type of electrical hazard than ground faults. Arc faults can cause fires, while ground faults can cause electric shock. Therefore, it is crucial to use the appropriate type of protection for the specific electrical hazard. In summary, the National Electrical Code mandates ground fault circuit interrupter protection for receptacles within 6 feet of a kitchen sink due to the increased risk of electrical shock in wet environments. While nuisance tripping may occur with sump pumps and instantaneous water heaters, it can be mitigated through proper grounding, dedicated circuits, and the use of time-delay ground fault circuit interrupters. Regular testing and adherence to manufacturers' instructions are essential for ensuring the effectiveness of ground fault circuit interrupters. Understanding the difference between ground fault circuit interrupters, ground fault equipment protection, surge protectors, and arc fault circuit interrupters is crucial for providing comprehensive electrical safety. Finally, consulting with a qualified electrician is always recommended to ensure compliance with all applicable codes and to address any specific electrical safety concerns. The 6-foot distance is measured horizontally from the edge of the sink. This means that if the receptacle is within 6 feet horizontally, even if it is not directly under the sink, it still requires ground fault circuit interrupter protection. The intent of the National Electrical Code is to provide a safety zone around water sources, recognizing that water can easily splash or spill, creating a potential shock hazard. The definition of a kitchen sink for the purposes of the National Electrical Code is not limited to residential kitchens. It includes any sink used for food preparation or dishwashing, regardless of whether it is located in a home, office, or commercial building. Therefore, the sink in the office kitchenette falls under this definition and requires ground fault circuit interrupter protection for any receptacles within 6 feet. It is also important to consider the height of the receptacle in relation to the sink. While the 6-foot distance is primarily measured horizontally, the National Electrical Code also takes into account the potential for water to splash upwards. If the receptacle is located low enough that it is likely to be splashed by water from the sink, then ground fault circuit interrupter protection is even more critical. The type of receptacle used under the sink can also affect the need for ground fault circuit interrupter protection. Standard 15 amp and 20 amp receptacles are the most common types used in residential and commercial buildings. These receptacles are required to be ground fault circuit interrupter protected if they are within 6 feet of a kitchen sink. However, there are also specialized receptacles, such as those used for specific appliances or equipment. These specialized receptacles may have different requirements for ground fault circuit interrupter protection, depending on their intended use and the specific electrical code requirements. In some cases, it may be possible to use a hard-wired connection instead of a receptacle for the sump pump and instantaneous water heater. A hard-wired connection involves directly wiring the appliance to the electrical circuit without using a plug-in receptacle. While hard wiring can eliminate the need for ground fault circuit interrupter protection at the receptacle, it is still important to ensure that the wiring and connections are properly installed and grounded to prevent electrical hazards. Furthermore, even with a hard-wired connection, the appliance itself may still require internal ground fault circuit interrupter protection, depending on its design and the applicable electrical codes. The location of the ground fault circuit interrupter protection can also vary. It can be provided at the receptacle itself, at the circuit breaker, or at a separate ground fault circuit interrupter device installed in the circuit. Ground fault circuit interrupter receptacles are the most common type, and they provide protection only at that specific receptacle. Ground fault circuit interrupter circuit breakers provide protection for the entire circuit, including all receptacles and devices connected to that circuit. Separate ground fault circuit interrupter devices can be used to protect specific areas or equipment, and they can be installed in a variety of locations. When choosing the location for ground fault circuit interrupter protection, it is important to consider the specific needs of the installation and the applicable electrical codes. Ground fault circuit interrupter circuit breakers offer the advantage of protecting the entire circuit, but they can be more expensive than ground fault circuit interrupter receptacles. Ground fault circuit interrupter receptacles are more affordable, but they only protect the specific receptacle where they are installed. Separate ground fault circuit interrupter devices offer flexibility in terms of location and protection, but they require additional installation and wiring. It is also important to consider the potential for nuisance tripping when choosing the location for ground fault circuit interrupter protection. If the ground fault circuit interrupter is located at the circuit breaker, a single fault on any receptacle or device on that circuit can cause the entire circuit to trip, potentially affecting other equipment or areas. Ground fault circuit interrupter receptacles offer the advantage of isolating the protection to the specific receptacle, minimizing the impact of a fault on other parts of the electrical system.